Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at how we can set up AWS EBS Persistent Volumes for EKS workloads. So what exactly we are trying to achieve in this video is we are going to create a AWS EKS cluster and we are going to provision the EBS volumes dynamically using the Kubernetes manifests to store the data from the workloads. So this is a way we can store our data related to the workloads, that is Kubernetes workloads, persistently in the EBS volumes. So let us try to understand the high level architecture that we are trying to implement over here. So this is the high level architecture wherein we will be setting up a EKS cluster and we will be deploying some workloads with a set of pods which will persist their data into EBS volumes. So this EBS volume is going to be dynamically provisioned using the EKS cluster. Basically we will be using the EKS EBS driver which will help us to dynamically provision the EBS volumes. So let us try to see how we can achieve that in this video. So let us get into the procedure of implementing this here. So as a first step, we need to ensure that the AWS CLI is installed and configured on your workstation. So for that, we can download the AWS CLI zip file. And then we can unzip and install it. So AWS CLI is downloaded. Let me unzip it. And now let us install it. So now our AWS CLI is installed and you can just configure your environment. So let me configure my environment quickly. So this will need your access key ID and the secret which will be unique to your account that you have on AWS. So now I have configured my AWS CLI with my access key and secret. Let us go to our next step. The next step is to ensure that kubectl is installed. So this is basically the tool that we will be using in order to manage the EKS cluster workloads. So for that we will need to install the kubectl. So now my kubectl is downloaded. Let me install it. So this is installed and you can just verify the kubectl version that is currently installed using the following command. So we have client version 1.32.1. Let me clear my screen. Now let us go to our next step, that is ensure AWS EKS is installed. So this is an important tool that we will be using in order to provision the EKS cluster on the AWS cloud platform. So for that we need to have the appropriate EKS CTL client or the tool installed on our workstation. So I am working on Fedora, so I'll be installing EKS client, EKS CTL client, which is compatible with the following architecture. So let me just set up my architecture. And the platform is going to be Linux, and let us try to download the package. Now the package is downloaded. Let us uncompress it and install the EKS CTL into our bin directory. So now we can validate the EKS CTL version that we have installed. We have the following version installed. Let me clear my screen and let us now go to our next step, that is step 4. So here is the important step wherein we will be creating a AWS EKS cluster with the AWS EC2 instance as the worker nodes. So let me copy this command and let us try to execute it. So EKSCTL is a utility that we'll be using to create a cluster with the name following in the region East 1. And we are not passing any further parameters, so it is basically going to create a managed EKS cluster with EC2 instance as the worker nodes. So this is going to take some time. Stay tuned so that the cluster is getting created. EKS cluster has been created. There are a few important things that we can get from this output. So there are two stacks that are created. One is the EKS cube stack, EKS cube stack cluster. This is where the control plane gets created, and there is one more stack that gets created that is related to the node group. So this is going to create our AWS EC2 instances that are a part of a node group. This is a node group, and they are there will be by default like two nodes, the EC2 instances that will be a part of that this cluster that will be created. So now that we have our EKS cluster ready, let us try to validate it. Let me clear my screen and let us go down and let us try to validate our nodes. So these are the EC2 nodes that are created for us, which will be acting as our worker nodes. Now let us look at the pods status also. So you can see like everything is running on the cluster. So now we have our AWS EKS cluster ready. The next step, that is step 5. Step 5 is to install the AWS EBS CSI driver. So basically in Kubernetes with the latest versions, the CSI drivers that were a part of the Kubernetes core platform have been has been deprecated and they have been separated out right now. So all the CSI driver implementations are carried out separately by the respective vendors who are providing that storage or the CSI driver implementation. So here like we will be trying to install the EBS CSI driver that is related to the AWS using the Helm package manager. So first thing, you need to ensure that you have Helm installed on your cluster, on your workstation. Sorry, let me install it by saying yes. So now my Helm is installed. Let us try to add the repository from where we will be installing the EBS CSI driver. So we have added the repository. Let us update the repository. So that has been successful. Let me clear my screen, and now it is time to add the install the repository. So this is the command that we will be using in order to install the AWS EBS CSI driver into the following namespace, and this is the chart name. So let me install it. So now my EBS driver is installed, as you can see. Let me clear my screen and let us try to validate our driver. So for that, like what we need to do is we need to get the list of pods in the kube system namespace with the label AWS EBS CSI driver. So this is the command. So this is the label related to the pods that are deployed for the AWS EBS CSI driver. So let me get the list of pods and their status. So you can see there are 2 pods related to the CSI controller that are deployed, and there are 2 pods related to CSI node that are deployed. So we need to verify the logs to ensure that the controller and node pods are working appropriately. So let us try to verify the logs for one of the controller. So my controller pod name is different, so let me update it now. So you can see like the CSI controller's pods to work, it needs to get the metadata information using the IMDS protocol or version. So this is the IMDS protocol that will be used in order to retrieve the metadata related to the AWS EC2 instances. So this is very important for the CSI controller to work, and if this is not working, then most probably your controller pods will not be in a running state. Now let us verify the logs for the CSI node. So my CSI node will be different. Let me update my pod name. So we'll verify for one of the pod. So you can see that it is looking good. There are no failures over here. Let me clear my screen, and now the important part is step 6, that is update the node role with the AWS EBS CSI driver policy. So here, like once you have created your cluster, there will be a node group role that will be created. Like this is the, so let me enlarge this one. So this is the node group that has been created in my side. So we need to update this node group such that we are adding the AWS EBS CSI driver policy over here. So basically this policy document provides the permissions to create volumes and manage your volumes dynamically. So that is what, like, we need to make sure that we are adding this policy to the following node group role that has been created in your account. So let me get it added quickly. So now I have added my the AWS EBS CSI driver policy to the node group that has been created in my cluster. So there are different methods other than this which AWS documentation or the AWS EKS documentation provides, wherein we can use the we can create a separate role and attach the policies. So this is the documentation that you can follow in order to carry out the same activity. But this I've been trying to make it working, but it has not been successful for me right now. So I have taken a different approach in order to provision the volumes. So here you can see they have created a IAM role that can be created using the following different methods, but that needs some prerequisites to be available. So those are some things that needs to be considered before following this documentation. So there are different methods like using EKS-CTL or using the AWS Management Console. Also, we can create a role and try to attach some policies and use that. So there is a method with the AWS CLA also that has been provided. So this is something that you can follow and try to see if this works. Otherwise, the approach that I am right now showing that should be working successfully. So let us go to our documentation again. Now that we have updated our role, the next step is applying the dynamic provisioning manifest. So here, we will be taking a sample manifest from the AWS EBS CSI driver documentation itself. So let us try to clone this repository. So I do not have Git right now, so let me install Git all. So now my Git is installed. So let me try to do a Git clone again for the AWS EBS CSI driver project. And now we can go to that folder wherein the manifests for dynamic provisioning are available. So that is available at the following location: examples, Kubernetes, dynamic provisioning. So let me clear my screen. Now we can apply the manifests that are available at the following location. So there are 3 manifests that are provided for us, which in this the first one is going to create a storage class. So let me show you the storage class. So it is going to use the following provisioner, and the next one, let us look at the claim. So basically we are creating a persistent volume claim wherein we are asking for a 4 GB volume to be made available for us in the following storage class. So this is the very basic claim that we are creating, and once that claim is ready, we will be utilizing that in the pod in order to store our data. So that is the very basic that we are going to do in this demo. So let me clear my screen and try to apply all this manifests. So all the 3 manifests the resources have been created. So now it's time to verify or validate the provisioning of the volume. So now if you can list the PVC, get PVC, you can see that the EBS claim status is bound. So there is a 4 GB capacity that has been allocated by creating a EBS volume store on the AWS side, and it has been allocated to us. And now if we look at the pod status, so let us see, the pod status is running, and you can validate it that it is running. We can also check the EBS volume that has been created under the AWS EC2 service. So you can see that 4 GB volume gets created in your respective region where you have provisioned the EBS volume. So now that we have validated our volume, so let us try to verify the data that is getting created on our persistent volume. So this is the data that is being written onto the persistent volume that we have just attached to our pod. So this is how we can create a dynamically provision EBS volume using the AWS EBS CSI driver and try to utilize that volume in our Kubernetes workloads. So this is what I wanted to share in this video about how we can use the AWS EKS CSI driver to provision the volumes dynamically and use it in our Kubernetes workloads. So once you have completed your activity, like it is better to delete your cluster so that you do not incur any charges. So here I'm going to delete my cluster, and this is going to delete all the CloudFormation stacks that and the respective resources that have been created. And it is always better to check your AWS console also if there are any stale like IAM roles that have been created which are not deleted as a part of this deletion. So you can go ahead and delete them as well. So that's all for now. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.